discussed about MAC address and we discussed about MAC address and IP address differences. Same there, same points only, nothing more. What is an IP address? Okay, it's a logical address. IP address is a logical address. MAC address is physical address. So IP address is logical address. IP address is uniquely identified device in the network. For example, I want to communicate from my laptop to another laptop in my network, or my laptop to my printer, which is connected in the network. I want to communicate from my laptop to another desktop in the network. How can we identify, are you in the same logical network or not? You are in the same physical network. In our office, two networks are there. In our office, in 70s Hyderabad office, we have two networks. Actually, three networks, sorry. For classroom, one network, and for the entire remaining room has two networks. But all are connected same. Physically, all are connected same only. So same network only, physically. But logically different networks. So if two devices want to communicate each other, both should be in the same physical and same logical network. How it can be a logical network? Because of the IP address. The IP address will defines the logical network. IP address defines the logical network. So that's it is. IP address is a logical address. These IP addresses can be assigned or changed or configured either manually. You can go and change the IP address, or you will get an IP address from the DHCP server. What is the DHCP server? Assign or configure an IP address to the client devices automatically. You have Wi-Fi router, you connect to the Wi-Fi router and you don't configure any IP address, right? You have smart TV, you connect it to your Wi-Fi router and you will get an IP address. You don't require to configure it. How it is possible? Because your Wi-Fi router acts like a DHCP server, it is giving an IP address to you. Do not think that is already my system has an IP address inside. Okay, that's the point. I think I no need to tell more explanation here because I think it is already completed for you. So I'm going to, if you have any doubts also you can ask me, guys, no problem. IP address can be changeable. Either I will change myself manually or it can be get it from the DHCP server. Like as I said earlier, when I was here, so when I'm here now, currently I'm here, I got an IP address from my office Wi-Fi router. I'm getting an IP address from there. DHCP service. I'm getting an IP address. Work completed. I went to my home. Then I will get an IP address from my Wi-Fi router as a DHCP, which is act like a DHCP server. Okay. IP address is changing automatically also. Okay. Or I will change myself IP address if it is required. Okay. IP address can be changeable by manually or automatically. And very important is every device must have an IP address to communicate in the network. I have a computer or a laptop or a mobile phone. I want to communicate in the network. First thing is to connect in the network is NIC. To connect in the network is NIC. And there is a form of connectivity. Is a wide device or wirelessly, you have to connect it, right? So that is some form, some media is required to connect, either wireless or wired. To connect, first of all, device required NIC from one device to another device or centralized device. You need a cable or maybe wirelessly you have to connect it. And then to communicate in the network is required an IP address. Without IP address, we can't communicate because there is no network, no logical network. If you don't define a logical network, you cannot communicate. How you identify a device? in the network so that we can able to communicate, right? You are traveling somewhere and maybe in your college, you should identify a person, right? With a name or some number you have to identify. Then only you can able to communicate. You want to send a mail to me. So you must know my email address. I must have an email address first of all. Then I will, if you know my email address, you can send a mail to me, right? The same way, a device want to communicate to another device, then both need an IP address. Both need an IP address. Without IP address, we can't communicate. Okay? All communications by IP address only. Guys, you open a different website. I open youtube.com, www.youtube.com. I open this studio.youtube.com, gmail.com, mail.gmail.com. What is this? And this is web.whatsapp.com, tocs.google.com, learn.microsoft.com. All are names only. But why I said all communications by IP address, your system will get an IP address of those servers from the DNS server. Okay. So actually you are communicating with an IP address only, but you cannot remember all the IP addresses of the different servers. So what you will do, you will ask DNS server for getting an IP address. Okay. But important is all communications by IP address. Every system must have an IP address to communicate in the network. IP address defines logical network. IP address is a logical address. IP address is a uniquely identified device in the network. What is the use of IP address? You can identify a device in the network, uniquely identify the device in the network. This is about your IP. IP addresses, we have two versions, IPv4, 32-bit, IPv6, 128-bit. IPv4 is look like this one. See, it is like it's a 32-bit in binary, but actually we get in the decimal format in the four uh, uh, octets in the four parts. We will write this 32-bit in the decimal format. IPv6 is hexadecimal format. This is look like this one. This is one kind of IPv6. This is another IPv6. This is another IPv6. Okay. Just understand the main points of IP address.
Yes, sir.
Uh, yes, sir. IPv4, IPv6. Very good, guys. IPv4 is 32-bit, IPv6 is 128-bit. IPv4, 2 to the power of 32, 4.3 billion IP addresses. This is the many IP addresses we are getting from the single IPv4. Total IPv4 addresses are 4.3 billion IP addresses are there. Total IPv6 addresses are 3.4 billion addresses, like a some decillion. That's the name is there called 3.4 decillion. Okay, so 3.4 into 10 to the power of 38. Those many IPv6s are available. IPv4 represented in decimal format. IPv6 represented in hexadecimal format. Hexadecimal format. IPv4 is look like this. IPv6 is look like this. It's here we have used dots. We have used colons. So only four parts. IPv4 only having four parts. IPv6 is a totally 8 blocks are there. IPv4 having 4 octets. IPv6 having 8 blocks. Okay, I will tell the calculation. So look at here. IPv4 is this is a 32 bit, right? If you write an IPv4, it's a 32 bit long. So like this. So binary, I'm writing in a binary form. Yeah. One means 8 ones, 8, 8, 8. Okay. So totally it is 32 bit. Okay. The same way it is like this. Ones also like this. What is this? This is the very first one. First one. This is the last one. It is goes like this. These are the binary numbers. Okay. So what the people done? So they divide this entire 32 bit into the 4 parts. Okay. So it is they put a dot here. Okay. And they put another dot here. Okay. Another dot here. So it is 4 parts. Part 1, part 2, part 3, part 4. So this entire 32 bit is divided into 4 parts. Okay. So this is our IP address is become that. And of course, you cannot read or write easily in the binary, right? So what is this then? They convert this thing into the decimal format. Convert entire this thing into the digital format. So it is decimal format. So this is, they will write in the decimal like this. This 8 zeros represent 0, 0, 0, 0. So what is this? This is 0, 0, 1. Because this is 1. This is 2. This is 3. Like this. 2. Okay. This is 3. You know what is this last one? Last one represent 255, 255, 255, 255. It means the starting one is 0.0.0. The last one is 255.255. This is your IPv4 range. Ranges means starting one. This is the last one. You guys understand this concept?
Yes, sir.
Very good. So we divide in an IPv4 into 4 parts, right? So each part is 8 bit. Each part is 8 bit. Each part, every part is 8 bit only. Okay. Each part is 8 bit. So, you know what is the maximum we are getting? This is 000 and this is 111. That is the last one. Okay. In this octet, it is the last one is 255. Because each part is 8 bit, we call this one as octet. Because 8 bits are there, we call it as octet. The first one we call it as the first octet. Then second octet. Okay. And then third octet. Then fourth octet. Okay. So this is first octet, second octet, third octet, fourth octet. So totally 4 octets are there. Some people for making easy certain textbooks, they use this concept like a W X dot Y dot Z. So W represent first octet, X represent second octet, Y represent third octet, Z represent fourth octet. Okay, so 4 octets, 4 octets. Okay, this is like some people, some textbooks, some people will represent like that. Actually, you should call always as an octet, first octet, second octet, third octet, fourth octet. This is for easy to understand because again, octet means some people like think there is something big kind of stuff. So for easy purpose, they use this W, X, Y, Z. This is like W, X, Y, Z. First octet, second octet, third octet, fourth octet. Okay, so that is this concept. And each octet size is minimum is 0. Okay, because we started like a 0 and finally we got 255. Okay, it is 0 to 255, maximum 0. Sorry, maximum 255, not more than 255. One English series I watched it. So almost there are speaking like they are perfect. Okay, they said like what is the IP address of some person to crack into a system. They just said 400.300.450.600. So I got a doubt that is all dots are okay, but where is this 400, 300 is came? Guys, any octet is not more than 255. Okay, not more than 255. The IP address starts from 0.0.0.0 to maximum. Last one is 255.255.255.255. This is the range. So it is not more than 255. Any octet is not more than 255. Okay. This is the starting one. This is the last one. Understand, guys? IPv4 total IP address ranges. Up to here. Don't worry, I will. Only two concepts. One is what is the IP address, classes, subnet mask, ranges. That's it. Not more than that one for today. Because I'm not also feeling well. I feel little uh, less energy and a little feverish also. Happen? No one is speaking.
Okay, sir. Okay, sir.
Okay.
Yeah, okay,
So
sir.
good.
Thank you,
So
sir.
no problem. Just
Mm.
we should complete the topics. Okay. Understand up to here or not?
Yes, sir, we got it.
Yeah,
We
good.
understand.
Right. This IP address total range is divided into 5 classes. Okay, 5 classes. So what are the classes? Class A, Class B, Class C, Class D, and Class E. Class A is range is 0 to 127. What is that range? It depends upon your first octet only. The range is defined at first octet only, not any other octet. Only if you look at an IP address, if you see the first octet, and you can understand which class of IP address. That's it. Okay. So based on the first octet. Okay. If first octet, so that's it is defined in the classes like a 0 to 127. Class B 128 to 191. Class C 192 to 223. Class D 224 to 239. Class E 240 to 256. Okay. So these are the classes and their ranges. Okay. So what is it? So based on the first octet only. For example, I'm typing in an IP address 54.9.100.240. So first octet means this is the first octet. 54. Where is the 54? Between 0 to 127. So it is, this IP address is class A IP address. Okay. So now I will take 154. 154, 120, 91. Which class it is? What is the first octet? $154.
Class C.
Class. It's a 154.
Class B. Class B, sir.
Check
Class
between. Yeah, very good. Okay. We'll get another one. So it's 189, 192, 223, 239. Now can you tell me? So class B, sorry, class B.
Class B.
Yes, very good. This class B. Whatever I've written, don't worry about it. See only the first octet. Always check the first octet. And which range in between? It is 128 to 191 is, this is 189. So it is in between this range. It is a class B only. Now tell me which class it is.
Class C.
Class C. So it is range 192 to 223. It is class C because this first octet. Do not see remaining things. కొంచెం లైటింగ్ ఉన్నాయి అసలు okay, very good guys. So that is how we can identify which class of IP address it is. Very good. Okay. If you check some textbooks where it may shows like this, okay, 1 to 126 in some textbooks. Okay, in certain textbooks it shows 1 to 127. In certain books it will shows 0 to 126 like this. Okay, so of course this is most acceptable. This is not acceptable. This is complete range, and this is something we used range kind of stuff. It means, guys, the 0 series, the 0.0.0, that's the very first IP address of IPv4 is reserved IP address and also called as unknown. Okay, unknown type. Reserved IP, unknown type. Unknown does not mean it's like that one. So it will use in certain protocols. Okay, used by certain protocols. Example, DHCP, client side it will use. Okay, client side. Default routing. Okay, default routing concepts, this IP address used like a unknown means DHCP client don't know where is a DHCP server. To such, it use this IP address as a unknown destination IP. Okay, so like that. And the entire G0 series also we are not using. Okay. Next 127.0.0.1. This is also reserved. If anybody asks why we are not using it, is reserved IP. Okay, called as local host IP address. It is a local host IP address. Okay, and also it is loopback. It is a loopback IP address. What is the purpose of loopback? It's for self-testing purpose to make sure your network drivers or maybe your self-pinging, like a system itself, like TCP/IP protocol is functioning or not. So for that one, we use for self-testing. It means how you use ping to ping 127.0.0.1. Okay, local host self system access app or service. Okay, for example, I make my system as a web server, then I can access it from it. For example, inside of my system, if I install MySQL application, MySQL server installed in my laptop, I want to access it. How can I access it? How can I access it? Okay, with a local host address. What is your local host address in IPv4? 127.0.0.1. Local address, local host address for IPv6 is colon 1. Okay, for IPv6 it is colon 1 localhost address. Localhost address IPv4 is 127.0.0.1 and also used for self-testing, self-system service access, self-system service access, app services access, exactly. And this 127 dot these things also not using. We don't use these things. That's what it is. Next. Guys, understand 0.0.0 and 127.0.0.1.
Yes, sir.
Very good. Class C is reserved for R&D. Maybe in some places may using, maybe in some such places they may use for some specific task purpose. But generally, in any public or private communications, we are not using. It may use for any some places, but we don't use it. Okay, in public globally, we don't use IP addresses from class E. And class D is multicast address. Multicast addresses to broadcast instead of broadcasting. So within the specific network or within the specific type of protocol sharing. Okay, we don't use multicast for one-to-one communication. Multicast used for between certain devices. It share information automatically using a multicast address. Example used in a routing protocols like RAP version 2, EIGRP, OSPF. These routing protocols in that place is used. Next one is when Windows deployment services, they use like a TFTP kind of stuff. Okay, it use TFTP kind of stuff. What we can say, bootp protocols. Memo. This is use multicast addressing to deploy an operating system into multiple systems. Okay, multicasting also we don't use it. What we are using? We do not use class E, class D. We do not use means we do not assign IP address to any device from class E, class D, this 0 series, 127 series, 169.254 series, that is APIPA series. We do not assign IP address to any devices from class E or class D, entire 0 series 0000 and as well as 0 series 127 series and APIPA also we don't use it. This 169.254. So what we use? So we assign IP addresses from class A, class B, and class C. Other than these series, remaining all we use it. Okay, remaining all we use it. Again, some conditions are there, they'll come in. Yeah. Because there are unicast IP addresses. So unicast addresses. Class A, Class B, Class C are unicast addresses. We can assign IP address from these classes except these three. Except these three, remaining we can use it. Of course, there is a private public is there. Again, that is we will discuss sometime. Okay. So this is about your IP addresses. Yeah, so there is a IP address, network portion, host portion kind of stuff, but I will add directly this point. Okay. Because I don't want to, I will explain that network and host portions. Okay. Guys, as I said, IP address, so if both side network is same, both systems are in the same network, they will communicate each other. But how it will understand both systems are in same network or not? By the network ID. How system will understand and get the network ID? It use the subnet mask. System use subnet mask to divide an IP address into network and host portions. And it tells the network ID of IP address. Okay. If both systems network ID is same, so they will communicate each other. The default subnet mask for class A is 255.0.0.0. This is the default subnet mask. Default subnet mask for class B is 255.255.0.0. Default subnet mask for a class C is 255.255.0. Okay. So again, I'm going to little back, guys. Here is important. What is an IP address? What we discuss? What is an IP address? Okay. And you know the points, right? So what is an IP address? What is IPv4? What is IPv6? If possible, try to remind me next class about IPv6. I will add some more points for IPv6. I will explain this, what is hexa, what is 8 blocks kind of stuff. I'll try to give, okay, some information at least, just list. Okay, we have two versions, IPv4, IPv6. About IPv4 classes, IP address. What is an IP address? What is the use of IP address? IP address, IPv4, IPv6, few basic differences. IPv4 classes, IPv4 classes, important. Next one is IPv4 subnet mask, default subnet mask for IPv4 based on the classes. That is important. That's why I skip small notes of mine and I jump there. But I will explain these things if you in case. Okay. What is network portion, host portions? Okay. What is importance of this network and host kind of stuff? I will explain it. Okay. Possible I will explain this. I skip the devices, I think. Okay. Yeah, I will next class means on Monday. I will explain about what we can say this network portions and all, plus how to assign an IP address, how to connect to two devices, so then how they will communicate each other. Okay, of course we missed this devices, right? I think Sciencer done these devices like a hub and switches, routers. I will give you a quick review, then we'll see how how you will assign an IP address and how we'll assign an IP address to two devices. How to test they can able to communicate or not. If test is failed, like if they are unable to communicate, so what we can able to do it. Okay. So different scenarios I will explain on Monday. Okay.
Okay, sir.
So also, if possible, read the notes I sent for your both hardware and networking. Anything you can. Okay. So any doubts also, guys? Any specific topic or specific questions? Just put in a group. Don't send a personal messages. Okay. Put in a group, sir. I don't understand, or I want information about this thing. I will give some notes, or maybe I will send some videos on it, so you can get it. So improve things. Okay. I think it is for today is enough.
Sir, tomorrow don't we have class?
Tomorrow we do not have class. Okay. So Monday again. I have to stop recording also. Sorry, I forget.